Let f of x equals negative 3x squared plus 6x minus 5. What is the absolute maximum value of f of x? Well, in order to find the absolute maximum value, we have to find its critical points. Critical points will tell us whether or not we have a maximum or a minimum, and then we can go from there. So how do you find critical points? Well, you take f prime of x and then set it equal to 0. So f prime of x is going to be the derivative of u, so negative 6x plus 6 plus 0. So set u equal to 0, like so. Subtract 6 from both sides. Negative 6 equals negative 6x. Divide both sides by negative 6. Divide both sides by negative 6. And positive 1 equals x. So the critical point is going to be 1. Now, what a critical point does is it tells you where your slope is 0. So if your slope is 0, that means you're going to either have a maximum, because our slope is 0, or a minimum, as long as there's a sign change. So we're going to make a sign table and make sure that there is a sign change. So at 1, we have a critical point. This is the sign table for f prime of x. So what I need to do is, since I only have one critical point, I have an interval of negative infinity all the way up until 1, and then from 1 all the way up until infinity. So I'm going to take a number like 0 and plug it into f prime of x and see if I get a positive or negative number. If it's positive, that means my function f of x is increasing. If it's negative, that means my function f of x is decreasing. I'll also plug in 2, because that's some number in the interval from 1 to infinity. So f prime of 0 would be me taking that equation right there and saying negative 6 times 0 plus 6 is going to be 0 plus 6, which is a positive number. So you're positive, which means you are increasing. F of x is increasing. Now we do it again. F prime of 2 is negative 6 times 2 plus 6, which is negative 12 plus 6, which is a negative number. So what's happening here is f of x is increasing, but once it hits x equals 1, it hits a peak up here and then starts decreasing. So we definitely do have a maximum. Okay, I just wanted to make sure of that. We definitely do have a maximum value at x equals 1. In order to find out what that maximum value is, you plug 1 into the original equation, not the derivative, because the derivative will give you 0. You plug it into the original equation because that tells you where it exists on the original function f of x. So regular f of 1 is going to equal negative 3 times 1 squared plus 6 times 1 minus 5. So negative 3 times 1 squared is going to be negative 3 times 1. 6 times 1 is going to be 6 minus 5. Negative 3 plus 6 is regular 3. 3 minus 5 is going to be negative 2. So our maximum value is going to happen at the point 1, negative 2. And so the answer is C.